Okay, good morning, afternoon, or evening, everybody. Welcome to the From Space to Solutions Access Visualization and Analysis Services for SWOT Hydrology data training webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we are going to go ahead and get started here. I will begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat, and you should see this located on the right side of your screen. If you don't see the Q&A panel, you can click on the three dots at the bottom of your screen to pull up your panel options, and then just insert a check mark next to the Q&A panel. A quick word about the chat. Participants will have the capability to chat with both the hosts and presenters, but not with all participants. So again, if you have any questions, please enter them into the Q&A panel on the right side of your screen rather than the chat so that everyone can benefit from that question. Today's webinar is being recorded. The recording will be made available online within a week of completion. Once completed, I will send an email to all of the registrants and participants that will include links to both the recording and the presentation slide decks used within today's webinar. As far as timing is concerned, today's event will be a little bit longer than our normal data training events. It'll be 1 hour, 1.5 hours long, with an hour allocated to the presentation and live demonstrations. And then a 15-minute Q&A period will follow. But depending on the volume of questions we receive, we may extend the Q&A session. But again, keeping in mind that we will have a hard cutoff of 3:30 p.m. Eastern. All right, at this point, I'm going to advance my slides here just for a second. All right. During this afternoon's webinar event, we have 3 speakers, 2 from NASA's Physical Oceanography Distributed Active Archive Center, or PO.DAAC, and 1 from the U.S. Geological Survey. Our first speaker this afternoon is Nikki Tebaldi. Nikki is a scientific software engineer at NASA's PO.DAAC and will kick us off today with an introduction to PO.DAAC, the SWOT mission, and its measurements. From there, Nikki will provide you with an overview of the Hydrocron API and continue with a live demonstration of how to use Hydrocron to work with SWOT Hydrology datasets. We'll then transition to our second speaker this afternoon, Merritt Harlan from the U.S. Geological Survey. Merritt is a Mendenhall postdoc and research hydrologist. She'll provide an overview of the Water Information from Space, or WISP, dashboard and showcase applications for SWOT hydrology data while also conducting a demonstration for accessing these SWOT hydrology products alongside USGS gauge data using the WISP dashboard. And then finally, our third speaker this afternoon is Nicholas Karpinian. Nick is a science data visualization engineer at NASA's PO.DAAC. He will introduce the SWOT River Reach Earthdata GIS Feature Service and conduct a live demonstration of the EGIS Feature Service for working with this River Reach data. Once Nick has finished with this demonstration and presentation, he will toss it back over to me, and at that point, I will open up the final polling questions, and then we'll transition directly to the question and answer period. Excuse me. Before I toss it over to Nikki, I'd like to say a few words about this afternoon's Q&A session. We'll have an additional panelist from NASA's PO.DAAC joining us for the Q&A session this afternoon, and I believe I saw him join. That is going to be Mike Gangle, who's a software systems engineer, and he'll join us. He'll be available all day during this event for questions and also during the Q&A session. We'll try to answer all the questions within the time allotted, but if we are not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. So with that, it is my pleasure to introduce today's first speaker, Nikki Tebaldi. Nikki, and at this point, Nikki, I'm going to stop sharing my screen and toss it over to you.
Great. All right, so hopefully you can see my slides okay.
I can, thank you.
Great. So thank you, Jennifer. I'd like to talk about the Hydrocron API today, and that's a service developed by PO.DAAC to aggregate and return time series data from the SWOT mission. I'll also complete a demo on its basic usage. But first, let's discuss some context for PO.DAAC and the SWOT mission. So PO.DAAC is the Physical Oceanography Distributed Active Archive Center. It's a NASA archive for oceanography and terrestrial hydrology data. PO.DAAC is one of several DACs which provide data publication, access, and user support as custodians of NASA's Earth science data. PO.DAAC distributes SWOT mission data, which includes low-rate and high-rate data products. The SWOT mission data is relevant to oceanography, terrestrial hydrology, and coastal user communities. Access includes download, in-cloud direct access, and there are also data services that support mission data, which we'll discuss today. There are many SWOT mission data products, but we're going to focus on the river vector and lake vector shapefiles. The river vector product includes vectors of river reaches and nodes. Reaches are defined sections of a river that are around 10 kilometers long, while nodes are points defined in a reach with around 200 meters of spacing between nodes. This is defined by the prior river database. The river vector product has an extent formatted continent scale swath and variables that include water surface elevation, slope, width, and river-derived discharge. It includes reach and node subcollection. The lake vector product includes vectors of lakes defined in the prior lake database and detected features not defined in the database. It has an extent format of continent scale swath and variables that include water surface elevation, area, and derived storage change. It includes observed lakes, prior lakes, and unassigned lake subcollections. All right, so let's shift our focus to Hydrocron. This is an application programming interface, or API. You can also think of it as a service that aggregates the SWOT shapefile observations and returns them as a time series, where there are many observations per specific feature. So as I mentioned, there's a variety of SWOT hydrology data products, from the Pixel Cloud product to the raster product, and then to the Level 2 river and lake shapefile products. And Hydrocron provides access to these river and lake vector products. They hold observations from rivers and lakes as defined by the prior river and lake databases, and these divide up the world's rivers and lakes and assign identifiers to them. The SWOT satellite uses the identifiers to record observations. The satellite retraces the same path every 21 days, so it's on a 21-day cycle, and each orbit includes an ascending and descending part, which is called a pass. So today we'll focus on the Level 2 river and lake data products, which are distributed as shapefiles, and each shapefile contains all of the features from an observed river or lake at one cycle pass. So there's essentially one observation per river or lake shapefile, but a common use case is to query these observations over a specific time range. This is difficult as a user will need to query all of the shapefiles for a time range, open up each one, locate the river or lake identifier that they're interested in, and save the data associated with that identifier. So this is where the Hydrocron API really shines. It aggregates the SWOT observations for river and lake shapefiles into time series data and returns the observation data in either CSV or GeoJSON. And then that data can be used in applications, research, visualized, or however the user wants. So let's dive into what Hydrocron is and its usage. Hydrocron is made up of two parts. The first is the database side of Hydrocron. It ingests SWOT granule shapefiles for river reaches, river nodes, and prior lakes. And there's the API side of Hydrocron, which receives user requests. It queries the database based on parameters passed in that request. It formats the database results and returns them as a response to the user. Some recent stats for the API include an average response size of 232 bytes, an average response time of 1.8 seconds, and an average of 107.5 hits per request, which can also be thought of as the returned observations. So Hydrocron powers both the USGS WISP dashboard, which we'll hear about in a little bit, and Kuwazi SWOT Viz dashboard. It's been exciting to see how Hydrocron can support different applications, and we'd love to hear from anyone who's interested in collaborating and providing feedback. So let's break down how to use Hydrocron over the next few slides. So thinking about the request and response interaction, the user queries the API with specific request parameters that describe the response they'd like to see back. The API takes the parameters of feature, feature ID, start time, and end time, and queries a Hydrocron database. The query returns results with the SWOT granule shapefile data, which has been aggregated into a time series of observations. The API then formats the response and returns it to the user. So here is the top-level URL for Hydrocron. When you make a request, you'll append request parameters to it. And we'll dive into those in a little bit. So here's that top-level URL again. Everything in orange is a request parameter, and you append values to it, and you get a response like the one shown on the right. You can also programmatically query the Hydrocron API using a variety of languages. Here's a Python example that sets up that top-level URL, defines the parameters, and then makes the request to Hydrocron. So let's talk a little bit about the request parameters. The first is feature, which is either reach, node, or prior lake. We don't yet support unassigned lakes or observed lakes in Hydrocron. And this is the type of data that you'd like to query for. There's also the feature ID, which is taken from the SWOT River database for rivers and the prior lake database for lakes. And I have further info on these resources in a slide at the end. There's also the start time, which is the start time of the time range to retrieve observations for, and the end time, which is the end time of the time range to retrieve observations for. There's the collection name. We currently return version 2.0 data of the SWOT vector shapefiles as the default in Hydrocron, but we also have version D data available, which you can specify using this parameter. There's the fields, which is the data attributes from the shapefiles that you'd like to return in the response. We have documentation on all the available fields on the Hydrocron documentation site. Output can be either CSV or GeoJSON, and compact is more of an advanced feature, which compacts or reduces the size of the response returned, and we have more details on our documentation site. So on the other side of things is the response. The default response returns JSON, which includes extra data like status, time, hits, and results, which you can see in the first rectangle on the right. Status is the status of the response. Time is the time it took to return the response. Hits is the number of observations, and results will contain the formatted time series data. The fields request parameter is what gets mapped to the results properties, which is the second rectangle on the right. And the output request parameter specifies what format to return the data in, and so this is sample GeoJSON. There's also some response codes to be aware of. We saw the 200 response code, which means the request has succeeded and the response has been returned. 400 means something in the request is invalid, and we attempt to send back an error message that highlights where the request may be invalid so that it can be fixed. 413 means the response is too large. We haven't seen this yet with our average response size of 232 bytes, so we're not quite bumping up against that 6 megabyte limit. 500 is an internal server error, which means something's going wrong on the Hydrocron side of things. 415 indicates an invalid accept header, and we have more information on our site about accept headers. I do want to note that the 400 code is also currently returned for queries where no time series data could be found. And it can be helpful to adjust the date ranges you are searching for to try to return more results. Errors are also helpful to consider when discussing Hydrocron responses. You should receive a fairly descriptive error message that indicates what may be going wrong. In this case, an invalid value is passed to the output parameter. We try to indicate that. So we list, this isn't an image. We don't support image in this parameter, and we try to also show what we do support. If you run into any issues and would like help, please make sure to send error responses if you encounter them. And speaking of help, a good place to look first for help is the documentation site. It covers examples, a user guide, the request parameters, the response details, and errors, and we do update it often. And then if you run into any issues or would like to contribute to Hydrocron development, you can also visit our GitHub repository. You can submit a GitHub issue if you'd like to request new features or functionality, if you've run into a bug that needs to be fixed, or even if you would like help troubleshooting. And if you'd like to contribute, please see our contributing guide and feel free to get in touch with any questions. Oops, clicked on the wrong thing there. So now we'll go into the demo side of anything. Oops. All right, got signed out of my slides. All right, so this demo will cover how to query Hydrocron to retrieve SWOT observations and visualize those observations on a map. And then we'll query Hydrocron to retrieve CSV data that is plotted as a time series. So the first thing we're going to do is import a couple of libraries. The first half of these is from the standard Python library and supports the execution of the code. The next two help us with visualization. Pandas helps us organize and format the data, and Request helps us communicate with Hydrocron. So we'll go ahead and import those. And then we will set up our request. So here's that top level URL again, and then all the parameters that we need to fill out. So I want to retrieve data for reaches, and I want to retrieve it for the specific reach identifier. And I use the USGS WISP dashboard to help me locate a reach near me. So this is part of the Connecticut River in the United States. This is also retrieved from the SWOT River database, and we have some more information in our resource list on how to access identifiers for both rivers and lakes. This is the start time, so this is with the start time and end time, this is the range that I want to receive observations from. I want to get GeoJSON output, and I'd like to get it for the reach identifier, the time string, water surface elevation, width, and the geometry. And then this final line goes ahead and makes the request, and we'll store the response in a variable. I want to pull out the JSON response, and I also want to pull out the URL, because what's helpful about that is you can navigate to the URL in your web browser and get a sneak peek of the results. So going back to the demo, one thing that I did was truncate the display of geometries because the coordinate list for reaches can get quite long. So we can explore this in the Jupyter Notebook, just be aware that the geometry side of things has been truncated for display. So let's look at the response here. We have a status of 200, which means everything went okay. We have the time, which is around 1200 milliseconds. Then we return 10 hits or 10 observations. Everything's stored in the results. And in particular, it's in the GeoJSON field because that's what we requested for the output. And so the GeoJSON is a feature collection indicated here by this type. And there's one feature per observation. So our very first observation starts at 0. We see the properties, which are the fields that I requested. So that's the reach identifier, the time string, which is the time of the observation, the water surface elevation, width. We also return units where applicable to specific fields. And then we'll also see the geometry, which again has been truncated for display, so we only see a single coordinate. So I'm just going to scroll through and we can see that there's one list element or one feature per observation until we get all the way to the end where we're at the 10th observation, or 9 because we started our list at 0. So let's pull out that GeoJSON data. We'll pull it from the results, and then we'll build a map using Folium. We will plug the GeoJSON data into the map, run a couple of other functions to make sure the map displays. And then sometimes it zooms way in when it runs it. So we'll zoom out a little bit. And here is a river reach near me on the Connecticut River between Vermont and New Hampshire in the US. The other cool thing about Folium is you can add a color range and plot things like the water surface elevation or width, so you can kind of see what those look like in geospatially. Let's move into the second part of the demo. This is a time series analysis using CSV data. So we'll go ahead and set up that request just as we did for the GeoJSON data. We've got our URL defined with all the parameters. Everything's exactly the same except for the CSV output. And then we'll go ahead and make that request. We'll pull the request out, we'll pull the JSON out of the response, and as well as the URL in case we wanted to look at that. And then we'll really highlight the specific CSV data. So we'll pull out a CSV string, which looks like this. It's a lot more compact than the GeoJSON, so that's something to keep in mind when you're thinking about using Hydrocron. And the cool thing about the CSV string is we can pass it into the string IO library, which gets passed to the read CSV function that's part of the pandas library to create a data frame. We do update the time string to a date time object, making it a little bit easier to work with dates and time. And we'll display the data frame. So we get one row per observation with the reach identifiers, the time strings, water surface elevation, width, and the units. So let's go ahead and plot the water surface elevation. So we'll set up a matplotlib figure, and then we'll plot the time information and the water surface elevation information. We'll add a couple labels and a title, and we'll get this plot. So we'll get a nice time series of water surface elevation for the time range that I was interested in for the reach. So let me just head back to our resources page. Make that larger so you can see it. So that's it for the demo. Thank you for joining us today. Please get in touch if you have a use case for Hydrocron, and feel free to submit an issue on GitHub if you have a feature request, find a bug, or just need help. GitHub is also what guides our future development for Hydrocron. I'll now hand things off to Merritt, who will talk about the USGS WISP dashboard.
Awesome. Thank you so much, Nikki, and hopefully y'all can see my screen all right.
Yes. Okay.
Okay, great. Well, thanks for the introduction and for the opportunity to present here. My name is Merritt Harlan, and I'll be talking about a new USGS web platform, Water Information from Space, which uses the Hydrocron API that Nikki just introduced to display and visualize SWOT data across the United States, alongside a couple of other data layers, including USGS gauge stations. For my talk, I'm going to give some additional short background on the surface water and ocean topography satellite. I'll then highlight how we're viewing and accessing that data through the Water Information from Space, or WISP, platform. And finally, I'll end with some varying water management applications using SWOT data. And to motivate why we're so interested in using and visualizing SWOT information is that SWOT is monitoring surface water at really vast spatial scales. And so relative to our traditional gauge monitoring network, we're able to access a lot more information on changing water levels and extents through satellite data. And so in Denver, Colorado, for example, we see SWOT coverage on lakes and rivers, including a number of small lakes and reservoirs. And in Washington, D.C., we see the Potomac River highlighted here, as well as a number of lakes and water bodies nearby. We really see the potential for using SWOT data to monitor our water resources in remote areas that have a lot of surface water, including the Yukon Delta in Alaska, where there's a large number of river networks and basins that don't have any traditional on-the-ground monitoring in place. And so SWOT is really our first picture into changing water dynamics in these regions. As Nikki highlighted, SWOT has a couple of different measured water features at the vector level that we're able to access through the Hydrocron API. And this include lake and reservoir polygon data defined in the prior lake database. And then for the river data, we have river reaches, which break down a river centerline into 10-kilometer segments, as well as river node data, which further breaks down the river reach product into points along the centerline spaced every 200 meters. I wanted to take a second to highlight the novelty of this river node product because we have water elevation and river width spaced every 200 meters along a river centerline, which allows us to explore novel hydrology applications, such as how slope might change up and downstream a river along varying distances. Now I'd like to transition to talking more about the Water Information from Space public data portal. And as shown here, we're viewing and displaying SWOT rivers and lakes alongside USGS gauges. And we plan to expand this in the future to include other satellite data products as well. You can access this dashboard through the URL linked here. You can also scan this QR code to access the database, the web portal. But we do caution that we've designed it primarily for web use on a computer monitor. And so while it has some functionality for a mobile device, it's slightly easier to use through a web interface. As I've mentioned, WISP uses the Hydrocron application programming interface to access SWOT data. And through this diagram, we see the SWOT mission is kind of the foundation of the data that we're using. And colleagues at NASA and JPL have developed these awesome solutions and tools to access this data, such as the Hydrocron API that Nikki has mentioned, or Earthdata GIS functionalities that Nick will talk about after me. And so WISP, we're trying to tie in the data and the data access portion to really have an easy to use interface that can help increase public understanding and exchange of this data. And an awesome feature of Hydrocron that Nikki has mentioned, but is worth repeating, is that we're able to get time series data very quickly and easily over national and global scales, enabling platforms like WISP and SWOT-Viz to exist. So now I'm going to dive into a short tutorial on how to use this site. We also have a formalized tutorial tab up here that will walk users through all of the different functionality. I won't go through it in detail, but I encourage you to revisit it. Our main feature to turn on or off data layers is this data menu on the left, where we can toggle on or off layers that we're interested in viewing. So here I'm visualizing the SWOT River data as alongside the USGS gauge layer. We can view river reaches either in this default blue color or colored by reach ID. And we can also view river node data. And so here, by clicking on a node, I'm querying Hydrocron to pull in SWOT data and also gauge data, which is nearby. We can access gauge data hyperlinked there. And we can also access SWOT data by downloading it into a CSV format enabled through Hydrocron. And here we can see all of the SWOT heights and widths that are displayed on the graph. In addition to the River Node and River Reach product, we also include SWOT Lake data. And so to access this data, again, you can click on a lake of interest and toggle on or off data quality parameters and download data to a CSV if desired. In addition to this main dashboard, we also include a What is SWOT informational page, and we link to a number of resources that have been shown, including documentation on Hydrocron and the SWOT user handbook, for example. We also have a detailed feedback form if you have any feedback for us, and as well as a frequently asked questions page that includes more information on where all of our data layers are coming from. We also directly hyperlink to the Hydrocron documentation page that Nikki has pointed out in case users want to directly use the API service to get at time series data. And so now I'm going to turn to ways in which we can use WISP and SWOT data to help with monitoring our water resources. And so one example is that SWOT is capturing different flood events. And so on June 25th in 2024, there was a flood event on the Blue Earth River at the Rapidan Dam in Minnesota. And as we can see from this picture, damages did occur downstream due to a partial failure of the dam. And so we're interested to use all the data available to us to really understand the extent of the flooding and the impacts. And so one such tool is accessing SWOT data. And on the left here, we have a screenshot taken from the WISP site, We're reviewing the Blue Earth River, and here we can see the Reach ID related to the SWOT River database, and a time series of water surface elevation, where time is on the x-axis, and then on our left y-axis here we have SWOT water height, which is referenced to an Earth gravitational model in 2008. And on the right y-axis we have USGS daily gauge height, also referenced in meters, but here we're using the native gauge datum. And so we'll notice that the left y-axis values and right y-axis values are different, and that's because they're referenced to two different datums, and also because sometimes our gauge is a little bit further upstream or downstream of the center point of a river reach, we wanted to just show a relative comparison. And so both time series are median normalized, but they have the same range so that we can track how well SWOT and a gauge go up and down over time. And we can see from this event that there was a large increase in the elevation of the lake or river during this time, up several meters, and that this increase in elevation is reflected in both the gauge and SWOT. And so in order to view this within WISP, here I'm going to use a functionality where I can search for a river by name. So I'm going to query the Blue Earth River. And that will zoom us on in to this river in Minnesota. And I'm going to turn on the SWOT lake layer as well as the USGS gauge layer. And here we're viewing a time series of the Blue Earth River. And we can see this flooding event highlighted during the increase in elevation that we see in July. And again, we can download this data. And the real highlight of SWOT in this case is that we not only have information at a gauge, but also upstream and downstream. So we can view the changes in water elevation downstream, but also in nearby lakes and rivers as well, to really get a sense of the extent of the precipitation event. Next, I'd like to highlight another use case. In this case, we're collaborating with the U.S. Department of Agriculture, and the USDA provides technical assistance for thousands of flood control and irrigation dams throughout the country. And around 6,500 of these sites are SWOT observable dams and reservoirs, and the vast majority of these sites don't have any traditional in situ monitoring in place. And so SWOT is one of the only ways that we can track changes in water elevation at these sites. And we're hoping to use SWOT elevation data to be able to improve early warning systems for when a spillway flow might occur. And spillway flows can cause downstream damages, and so they're of great concern to the Natural Resources Conservation Service through the USDA. In order to access the water elevation data in WISP, first I'm going to filter to the state of Oklahoma where our partners are based, and I'm going to turn on the SWOT lake layer. And first I'm going to click on a lake or reservoir that we have USGS gauge data. And here we're able to compare the accuracy of SWOT in a gauge. But again, a real promise of SWOT is that we have changes in elevation data outside of places where we have a gauge, including the many areas that USDA is trying to monitor through these flood control dams. The final example I'll highlight is we're partnering with the Alaska Department of Transportation, and they're interested in using SWOT data to help with their hydrologic models, to help with the design of safer bridges. And so in this example, I'm looking at data from the Knik River in Alaska, where there's a large bridge, and there's a need to continually update the hydrologic models related to these bridges and for new bridge designs in the state. And relative to the continental U.S., Alaska is quite remote and difficult to monitor with in situ gauges. So here to view this data through the site, I'm going to focus in on Alaska. And again, I'm going to use the search functionality to find where the Knik River is. and filter on into the site. And I'm going to click on a reach of interest to view the time series and elevation. And in this case, I'm also going to turn on the ice-affected data layer in order to see those values as well. All right, so that's sort of just a short snapshot of the capabilities of WISP, and I really encourage you all to check it out. And in conclusion, SWOT is, vastly increasing the number of lakes, reservoirs, and rivers globally. SWOT data in the United States are publicly accessible through WISP. And if you're interested in international rivers and lakes, I really encourage you to check out the SWOT Viz portal. And if you're interested in working with us to make WISP global, please feel free to reach out as well. We also encourage you to discover your own use for SWOT data on WISP, and please reach out if you'd like help with that. And I'd also like to thank the WISP developers, including Chuck Hansen's team at the USGS California Water Science Center, and the developers of Hydrocron, and for NASA for the opportunity to present. And with that, I'd like to turn it over to Nick to talk more about GIS features and accessing SWOT data there.
You Merit. Share my screen. Okay, so hi everyone. If you see my screen, please let me know. But my name is Nicholas Tarpinian, and today I'm going to be talking about the SWOT River Reach EGIS Feature Service. So everywhere from how to access it, what the services are, how to visualize it and analyze it, and a bunch of different GIS tools and web browsers. So to start off, we're proud to announce that the SWOT River Reach GIS Feature Service is finally available. It is public for you guys to all check out. So this was built through NASA's Earthdata GIS or EGIS Enterprise Initiative. If you don't know what EGIS is or EGIS, it is NASA's. It's part of NASA's initiative where they want to make NASA data more GIS friendly. You're able to plug in all this NASA data within ArcGIS Pro or QGIS, where in the past there's always been difficulties. So through this, we're able to build the SWOT River Reach collection. So we have two services available. We have the full back catalog version of version C or 2.0, and then version D, which is the forward stream with the latest observations. This is going to be available in both the ArcGIS REST Service endpoints and also the Open Geospatial Consortium endpoints, or OGC. So you're able to plug in these endpoints in your ArcGIS Pro, QGIS, or even Python Jupyter notebooks to analyze and visualize. So background and detail of what these services are. So like I mentioned, there's two different services. So we have version D and version C. This includes the full attribute table records. For version C, the time range is from March 29, 2023, all the way up to this year of May 3rd, 2025. And then for the version D, that's the latest observation. So it started from May 5th, 2025 till present. So it gets updated daily with the latest available data sets. And then we also have, you could think of it like a subservice or a sub-collection. We have the version D and version C basic collection. So the reasoning behind basic is, so when you look at the product description documentation and for the attribute table, there are two categories. There are the basic and the expert. The basic are the Karen measurements from the SWOT satellite. There are the measurements as is. And then the expert is a more detailed explanation, or more like CalVal, of how those observations were derived from. So what we wanted to do is just get a basic attribute. So this dropped down from the full attribute table record from like around 126 all the way down to like 26 attributes. So this will allow for a lot quicker load times and visualization. So you only have the main attributes to look through, but we do have both available. And with these services, due to the amount of records, we also set in zoom level extent. So whenever you're zoomed in at a minimum of 1 in 5,000, which is like city parcel level, all the way up to 1 in 10 million, which is continent level, that's when the geometries will show. So anything below or above it, the geometries won't load. But whenever you're within that range, you're able to see the geometries load. The image over here, this is our EGIS homepage, where you find all other NASA GIS datasets, which I'll go through later on. So where do we access these services? So like I mentioned, that you could access through the EGIS homepage. We also have the PO.DAAC cookbook, where not just listing all the available services, but we also have plenty of other user guides and tutorials that you can look through. But I wanted to go into detail about what these endpoints are. So we have the ArcGIS REST API, and then we have the Open Geospatial Consortium, or OGC endpoints. So with the REST APIs, we have two different endpoints: the feature service, which you're able to visualize and query off of the attribute table. And then on the visualization side of things, you could also change the symbology of the geometry based on a specific attribute. And then for the map image service, it's more for quick dynamic tiling. So you get tiled images. So if you want to just quickly display it on a map, look at a specific river reach, you're able to do that. But you could, when you select the river reach, it also reads into the underlying attribute table record of the feature service. You just don't have you won't be able to do like time series charting or visualization based on attributes, but you are able to do it with the feature service. But with the map image service, it's more for a quick visualization. And with the OGC endpoints, we have the web feature service, which you're able to query a subset of the feature service. This is great for QGIS. And then we also have the latest OGC feature layer, which is similar to WFS, but with more of the updated standards, like get it in GeoJSON and then a lot faster response time. Now, I want to show how you could access these services. So when you have your content landing page, there's two access points. We have the first one, you could either in your web browser, you could open in the map viewer. So you could just quickly visualize in the map viewer, as you can see in this image on the right. Or you could grab that endpoint and then plug it into your QGIS, as you can see here, or your ArcGIS Pro. Now, I wanted to also highlight some of the capabilities we wanted to enable with the feature service. We have here ArcGIS Pro image examples. The first one was, like I mentioned, visualization based on symbology. So here on this image, we visualized the feature service based on water surface elevation. So you're able to do that and select a variety of different attributes to change the symbology on. And then also you could create a time series chart with the service as well. This is in ArcGIS Pro, like I said. But selecting a bounding box of a specific region, expand the time range, and you get a long time range of specific attributes. And then I also wanted to highlight Python. With Python, it's great if you want to just do a quick query. So we have here our URL of our service endpoint. And then for this example, I have, I want to search for the Colorado River. So you could query the river name Colorado River. You'll get your response, and then you're able to display it with like an interactive GUI like leaf map. So you can see here. So we were able to quickly query all the reaches that are named Colorado River, not just the main Colorado River basin, but also there's Colorado River in Texas. And then you're also able to query based on a specific reach ID and plot it like with Matplotlib as well. Now, I would like to demo and highlight all the different ways of accessing. So first off, here is the NASA Data GIS, where we not only have the SWOT layers, but we have from every other archive center as well, or other science enabling centers. They have all their available layers within EGIS, and when you select gallery, you have access to all these different services. So we have here our GIS chapter of our PO.DAAC cookbook. So we have here, which I'll go over, the list of services. We have here a step-by-step tutorial guide on how to access it within QGIS and ArcGIS Pro, as well as many query examples with Python. So for the list of services, this page, you'll see all the available services. what the time range is, what the zoom level extents are set to, and all the individual endpoints. So easy access page of like, if you want just WFS or OGC or map image, you're able to do it you're able to look through on this page. And so this is our content page. So product description, the DLI, this will lead straight to the PO.DAAC dataset landing page. And then if you have any questions, please let us know. This is where you could go view in the map viewer. And then this is also where you get access through the REST endpoint. I also wanted to showcase with this endpoint with the map image layer, when you open it up, you also have access to the WFS and OGC endpoints as well. And I also wanted to highlight this view in, there's this ArcGIS Earth. It is not strictly ArcGIS Earth, but once you select it, it'll download you a KMZ file. With that KMZ file, you're able to load it up here in Google Earth Pro. So this is great. If you just want to quickly visualize it on a map like Google Earth, you're able to do that. So whenever you're within that map image REST endpoint, you select this, it'll just give you a KMZ file linking to that REST endpoint, and then you're able to visualize it in Google Earth Pro. Now, to go back to the browser, here is also the feature layer. All the content pages are the same. One other thing to note, you do not need a sign-in account. You do not need a login account or anything like that. This is all open source and public. So whenever you're on this content landing page, you could just select Open in Map Viewer, and it will lead you to the web browser of the map viewing web browser. So with that layer, whenever you open it in the web map viewer, we have here the layer. It is grayed out because we are not in our zoom level extents. You have our time slider here. And so once you start zooming into an area, that's when the geometries are going to start showing, and you can see it is not grayed out anymore. You see this blue dot, that means that it's loading the records. We have here like around the 21-day mark, more or less, of what of SWOT goes over across the globe. You could change it, and it should change. It'll start disappearing some of the geometry, so it'll just start showing those individual paths based on the days of observations. You could expand it. You could just get a more global view. You could also select a specific river reach. Let's wait for it to load. And based on the time level, the time scale extent you have here, that's the number of records or observations you're going to see here. So you select this, and then you could select all the other observations there are for that specific river reach, and then you'll be able to view all the observations within the attribute table. So this is just a great quick visualization within the web browser. Next, I want to highlight QGIS. So with QGIS, what I would suggest is you don't need to do this, but from my preference, and it's a lot easier for you to load these features. Grab a base map, plot it on the map, and go to a region of interest that you want to research. That way, once you're in a certain region of interest, it's able to load a lot faster. And for demo purposes, I've already loaded one layer, but it does not take too long. But whenever you go to your data source manager, this is where you select like new, and then you put in the name of the service and the URL, that REST endpoint, and then you're able to connect to it. Same with the WFS and OGC API, best way, select new, put in that endpoint, and then you could build the query. You could just add it. It will take time to load. It'll load everything. Or you could just query, let's say, a specific value of, let's say, slope less than 10 or something like that. Like, you're able to query, and it'll grab those features for you. For the demo purposes, I chose the ArcGIS REST server to showcase. I would suggest, like I said, go into your region of interest and select this only request features overlapping the current view extent. This will give you a subset or the extent of your region of interest. And then once you click add, it will load pretty quickly. So here I have it loaded up already. And this was the view extent. It's already cut off. So this was the view extent that I had loaded it into. And this is great. And once you zoom out, there's no zoom level extents like set within ArcGIS. With QGIS. So that's why another reason why it's good to just look at a certain region of interest of choice. And again, with this, you can do time series chart within QGIS and then look at its attribute table. And lastly, I also wanted to highlight ArcGIS Pro. We have here the version C basic. So this is over 2 years of data. It's a lot of data, but it will load. What I would suggest is lowering the timescale extent first. Go to your region of interest and wait for it to start loading. This is a live demo, so please bear with me. So it should start loading. Yeah, some of the other capabilities you can is, of course, time series charting with this. If you feel like doing some type of analysis, you're able to use the geoprocessing tools. So it looks like there is a little snag here. Sorry about that. If they come out, there it is. Yeah, just give it some time. It'll start loading here. Yeah, it's a lot of records it's loading. For this service, there are over 26 million records in the attribute table. So this is why I also suggest to lowering the timescale. That way it's not reading and trying to load all 26 million records. So yeah, this is it will visualize. Just give it a moment. But one other thing I wanted to highlight, you're able to do time series charting as well. If it was, yeah, I have it loaded here. Here's a time series chart that I previously loaded. So we have here date or number. There's the time string, of course, but there's also date time that we specifically created for the feature service. And this is because in GIS, it does not like, sometimes it likes working with time string data type, but we created a specific field for date time data type. That way you're easily able to do time series charting. So we have that as the date or time. No aggregation. You can select your numeric field and then you just select the river reach and then expand the time slider as well as you see fit. To finish off, here are some of our resources. So again, like I mentioned, this GIS cookbook is where we list all the available resources, and the services. We have the GIS chapter. I have the EGIS access page for step-by-step tutorial, and then the Python EGIS access, and then feedback is welcome. So please check out the service and provide any feedback that you see fit, or if you really like it, please let us know. At PO.DAAC, we also have this cheat sheet where everything's SWOT or any other tools to access SWOT. So there's the landing page or data search, etc., and of course Hydrocron and EGIS. So yeah, I would like to thank you and really appreciate this opportunity.
All right. Well, thank you so much, Nick, and thanks to everybody. At this point, what we will do, I'm going to open up the final polling questions really quickly, and then we'll transition directly to the Q&A section. All right, everybody, opening up the poll. Okay, folks, you should see the optional end polls on the right side of your screen. We really appreciate your feedback. And with that, let me transition. There were a couple of questions asked in the chat, and so I'm actually going to start with one of those questions and then transition directly to the Q&A. And I would ask all participants, if you could, please enter your questions into the Q&A panel so that all participants can benefit from that query. The first question is, could we download all of the data for all of the reaches at once?
Yes, you can. You can load all the reaches at once. It will load. If this is for EGIS specifically, it is possible. Just give it give it a couple seconds for it to load, but you will able to get more of a global view.
All right. Well, thank you very much, Nick. And then there's a question that has already been answered. A couple of folks were asking whether or not WISP can be used globally or if it's just for the USA. And, both Catalina and I responded, that it's currently available for the US, and Catalina provided an access point for the global river through the SWOT Viz capability. So another question is, it seems that the SWOT and USGS data are correlated, but the magnitudes are different. Have there been accuracy assessments of the SWOT data at gauge location?
I can take that question, and that's a great one. I have been working on an accuracy assessment publication, and I'm just getting ready to submit that, and I'm happy to share it out once it's available. And there have been some other accuracy assessment papers too, especially outside the United States, and I can follow up with some links to those if that's of interest. And so, yeah, we are finding that there can be different magnitudes, that SWOT elevations do have errors in them, and that can range from a couple centimeters to a couple of meters in some cases. And so it's definitely needed to do some quality assurance on the data at times. And so, yeah, happy to follow up, or feel free to reach out to me directly if you'd like to talk more about my work with the USGS gauges, or other publications that have come out recently too.
All right, well, perfect. Thank you so much, Merritt. Just moving on to the next question here. I was just curious if there is any raster time series API for the SWOT Level 2 HR. By raster time series, I mean a GIF or something like that can be used to visualize flood events.
So we don't have raster data included in the Hydrocron API, but if you want to submit a GitHub issue, that is definitely something that we can start to prioritize and think about what that might look like for future.
Well, thanks so much, Nikki. Alrighty, I'm going to move on to the next question. Is it possible to convert the SWOT data to the streamflow data? If yes, what is the method?
Nikki, do you want to take that, or I'm happy to also take a stab?
Here, I'll let you take it.
Yeah, that is a great question. And it is definitely possible to convert SWOT data to streamflow data. And that was like part of the design of the satellite, to have simultaneous extent and elevation. Allows you to kind of map volumetric changes in rivers and lakes. There are a bit of parameters to sort out and getting all the way to streamflow, because SWOT isn't observing the full river channel. It's just observing kind of that top elevation as it changes over time. And so there will be an official SWOT discharge product that's expected to come out at some point, maybe in 2026 or later, I would say. And I believe that the plan is to ingest that SWOT discharge product into Hydrocron and have it included as a variable output. If you're eager to get discharge data before then, there's also a whole repository that describes the different methods of streamflow parameter estimation. And there's also been a number of publications that have come out that describe how SWOT discharge is being computed. And we can also follow up with links there.
Okay, excellent. Thank you, Merritt. Let's see. The next question here is also in the chat. Do high salinity levels in salt lakes pose challenges for SWOT's Ka band radar measurements, particularly in terms of surface backscatter and elevation accuracy?
I don't directly know the answer to this question, I'm sad to say. I have not seen those challenges directly, but I have not specifically studied high salinity lakes to check. I think one challenge with some high salinity lakes is their water body size. And so just focusing on the vector data products if they're so big that you're comparing a 1-point measurement from a gauge to the whole entire water body, it can be hard to know if you're comparing apples to apples. But we can try and, I don't know, follow up maybe with some folks who are working in this space more.
Sure.
It's definitely a topic of interest too.
Sure. I think there's definitely an opportunity to follow up with this webinar participant offline, and I will provide the Q&A logs and chat logs to all of our panelists. Excuse me. So the next question is, how can you match the location of a SWOT node with a USGS station when comparing the WSC from both where comparing the WSC from both makes sense and it's accurate? For example, sometimes the USGS station is along the riverbank and the SWOT node is at the center of a river. Sometimes they aren't in the same elevation. Can you describe how accurate this is to compare the WSC of these two, and how can the analysis be improved?
That is another great question and kind of challenge that I've grappled with in my research of trying to compare both of those. I have matched nodes to gauges by spatially intersecting, what is the closest node to a gauge station and what's the closest reach to a gauge station. Now in WISP, we wanted folks to be able to compare many nodes with a gauge, and so any node that is part of the closest reach to a gauge station can be directly compared. But I think, as you point out, there's dams, there's other river obstructions where sometimes even the closest node might not be that representative of what the gauge station is measuring. And so I think in order to improve this pairing, it might take some, matching and seeing how well those time series correlate, but also maybe looking directly, what does the river look like in this section? And are there obstructions there that are maybe making this comparison not that representative?
Thank you, Merritt. Okay, so our next question is, I'd like to hear more about quality assurance and uncertainty of the parameters being pulled from the satellite datasets and placed into the time series.
I think, so for Hydrocron, right, Nikki, all data is being entered, even observations that are not valid, I believe, are also within Hydrocron. And so I think on their side, they've kind of left it up to the user to do the quality assurance. And in WISP, for example, we're using the summary quality flag to kind of show what data is populating on the plots. And so we're only showing good integrated quality data on those plots, and we're filtering out potential ice coverage. But I think there's a lot of opportunity to improve upon this quality assurance. And I've seen a couple different approaches. But yeah, I know, Sharon, you've done a lot of quality assurance for your elevation data products, and it could be interesting to follow up to see what advice you may have.
All right. Thank you again. And our next question is a question for Nikki. I just wanted to confirm that the URL endpoint you showed for the SWOT PO.DAAC URL does not require Earthdata login or authentication.
No, it doesn't. If you have a more operational use case, we would love to hear from you and talk about getting an API key, which will sort of help isolate your traffic and like your queries that you're making. But in general, it's open to use.
All right, perfect. Thank you, Nikki. The next question is, I haven't responded to this yet with a text, so my apologies, Nishant. So the question is, the way you show us to download the data for a particular reach, we have to fill in the reach number. Do we have to feed all the reach numbers through some Excel or CSV file in the Python code?
Yeah, so I'll try to put a link in the chat. You're right. Hydrocron you'll need to identify your identifier for reach or lakes ahead of time using the SWOT River database or the prior lake database. And how you store that and pass that into the Python code is totally up to you. You could come up with a list. You could store it in a file or a CSV. And we have a couple of different ways that you can actually locate your reach identifiers or your identifiers of interest. I think the USGS WISP dashboard's a great way to sort of manually identify your region of interest and start to locate things. There's also the SWOT Explorer site. And then we also have the feature translation service, which I will share in the chat with I'll point you to the documentation that might help you more programmatically query that service to pull out identifiers. But that is only available currently for SWORD. We would like to integrate the Prior Lake database, so it's only available for rivers.
Okay, thank you so much, Nikki. All right, I'm going to hop back up to, just bear with me for one moment. Thank you. I'll make sure, I'm trying to make sure I haven't missed any. All right, moving down to our next question. All right, so the next question is, as evidence emerges that SWOT can measure rivers narrower than 100 meters, is there any plan to expand SWORD and corresponding tools like WISP and SWOT Viz to include additional rivers?
So there are new versions of SWORD that come out, I would say, every like 1 to 2 years. And I think anecdotally, I've heard that is an interest and focus is to look at including rivers that are, in that 30 to 100 meter range. And certainly within SWORD now, there's also rivers that are down to 50 to 100 meters. And I think currently the version of SWORD is SWORD 17B. And so I think there might be plans to continue to develop that data set. And then in terms of ingesting the SWORD data set into WISP and SWOT Viz, we're definitely going to continue to update the river database as it has new versions. And so hopefully as the river networks improve over time or include more rivers, we'll propagate that to these web visualization tools.
All right, great. All right, so the next question is, could you provide the link to the repository for the parameters to convert the SWOT data to Streamflow?
Merritt, do you think it would be I was thinking of sharing the SWOT Confluence organization, but we don't have a lot of documentation and sort of how to execute things. Do you think that'd be appropriate to share, or did you have another resource in?
Yeah, so I just put the Confluence link in the chat, but there's also a great video overview from Hind Ubanis, who's on the SWOT science team.
That's right.
And so I will paste that in the chat too, as well as maybe Costas's discharge publication that came out somewhat recently and has some description there. So yeah, feel free to look in the chat for those links.
I really appreciate you doing that. Thank you. Okay, so our next question is, how does SWOT data perform over large versus small lakes, and in what ways, do wave dynamics influence the accuracy of its reading?
I think this question is also still being explored. And it is challenging to evaluate at scale because we don't have a ton of monitoring stations necessarily on really small lakes. So a lot of our gauge networks are maybe biased towards slightly larger water bodies that I've looked at personally, I think. So yeah, room to explore, but I have seen kind of accurate, SWOT elevations down to, say, 0.01 square kilometers. And I think that there's some interesting studies coming out that are looking at the effects of waves on that elevation and actually seeing if SWOT can help us understand wave dynamics in lakes and kind of predict the wind on lakes and stuff like that too. So definitely a topic of ongoing research, I would say.
Thank you. And thank you, Nikki. I can see that while I am working the Q&A channel, that you are also adding some resource links to the chat. So really appreciate that. And thank you, Merritt, for your responses. So the next question for you for the team is how can I extract and stack time series data for a specific attribute? For example, water surface elevation or water fraction or classification from SWOT HR picks the files at a given geographic coordinate, considering that the exact point locations may vary across different granules for the same region and the dataset is large.
So we don't serve out for the SWOT HR Excel Cloud data. We don't serve that out on Hydrocron. So that's something where you'd have to dive into those individual files, which is one of the problems we solve for the vector data. But if you're, like I mentioned, feel free to submit a GitHub issue, and that's something we consider and maybe see if it's possible for us to integrate. We can also gauge interest and think about what do our next services look like as well.
All right, thank you, Nikki. The next question is, are Hydrocron data being used in practical applications such as dam management or hydroelectric power generation? Excuse me, I can't see the rest of the question because of the chat here. My apologies. Let me go back down. All right. Okay. My apologies. Are Hydrocron data being used in practical applications such as dam management or hydroelectric power generation? If so, could you provide some examples?
That's a great question. I've been gathering user stories, and I have, example of like dealing with flooding risks and things like that. Fortunately, I haven't heard from anyone using it for dam management or hydroelectric power generation. It certainly seems like that's something that's possible. And so I would love to hear, I too would love to hear from folks that might be thinking about using it that capacity. And, if there's any additional support we at PO.DAAC can provide for part of that. Mara, have you heard about anyone using that in the WISP dashboard?
Yeah, so we've been working with the U.S. Department of Agriculture, who is, I would say, not yet operationally using the Hydrocron directly, but we're doing a lot of tests to see, on a subset of lakes that we have validation for, kind of what is the benefit of ingesting SWOT for those early flood warning detection systems. So we're kind of working towards an operational framework, but doing a lot of testing in the short term to make sure we're, ingesting accurate water surface elevations, for example, and that we have some validation before we just apply it at scale.
Okay, thank you, Merritt, and thank you, Nikki. And so let's see here, I'm going to move back up. The next question is, how does SWOT handle rivers that meander? Is the node location fixed, or does it represent a general area that covers rivers that move within the channel?
Nikki, feel free to answer this as well. But so the SWOT River database that the observations are tied to is static. It goes through updates as, the SWOT River database moves from version 16 to 17B. But each node does have a meander variable associated with it so that we have a sense beforehand how much that channel might meander. And also, I think SWOT data are kind of, SWOT looks for data over a wider area. And so even if the channel is moving, it might be pulling data from a little bit away from the XY location of that node point. So if a channel does move, we still might be getting, accurate water elevation data. But there are some challenges if the SWOT River database is really far away from the network, and then we aren't pulling in those values as well.
Okay, thank you, Merritt. All right, so our next question is a use case is presented first and then a follow-up question. So the use case is, I attempted to use the Hydrocron API for retrieving reservoir surface area time series, but ran into an issue. The reservoir polygons in my dataset were only partially covered. even when combining multiple lake features from the prior lake database. How can I obtain an accurate surface area time series in such cases?
So that's a really great question, and I'm happy to dive into that and explore that more with you if you want to submit a GitHub issue or contact me directly. But I'm wondering if the observed lakes or the unassigned lakes, which is another part of the lake vector data products, might be helpful in this case. I haven't worked with those extensively, but we are working on integrating those into Hydrocron. So then that's something that you could query and see if that fits the reservoir polygons that you're using. Right now, you'd have to access the lake, those specific lake shape files directly. But it may be helpful to start to explore those just so you could see like if it's going to meet your use case. And then once they're available in Hydrocron, you can query Hydrocron for them.
All right, perfect. Thank you, Nikki. We have entered our extended Q&A period, and we'll continue forward until 3:30 p.m. Eastern. All right, so the next question is, with SWOT and other relevant data sets, are we able to get water salinity, temperature value for multiple depths other than only the surface, which is usually helpful for water quality research like harmful algal blooms, microplastics, etc.?
For this question, I would definitely encourage you to check out some other satellite sensors. SWOT is not really, doesn't have a river temperature or salinity data product that comes from it, but it does kind of map, changes in volume of these lakes at pretty fine scales. But for looking at harmful algal blooms, there's been a lot of research on other optical sensors like Landsat or Sentinel-2 and trying to match, the color that the satellite is observing to the HAB's potential. I think there's a lot of potential for multi-sensor fusion with SWOT and other satellite sensors to get at that question of water quality.
Thanks, Merit. And I am responding. So I think, there you can access PACE data for salinity. There are other satellites which have at our ocean biology distributed active archive center that offer up these products that you were mentioning, and also at PO.DAAC in terms of the sea surface temperature data. But I will respond via email and putting my email in the chat, and then I will loop you into additional data centers if needed. And of course, you can always enter a ticket into the Earthdata forum, which is https forum.earthdata.nasa.gov. If you think of something down the road, feel free to make use of that help resource, community-based help resource. So we've got subject matter experts from all of the discipline-specific data centers, science teams, and more. Let me finish my response here. All right, so moving on to the next. Right, how can I accurately obtain? Oh, I think I actually asked that one. Excuse me. That's right. Now let me check back up to see if I've missed any. Let me check the chat. Okay. Thanks for putting that in there. Okay, so, and I'll follow up with the user and provide some direct links for data sets related to PACE. They also have some recent webinars and some Jupyter notebooks and tutorials that might be helpful. Okay, so the next one is actually in the chat. I'm looking at the SWOT Confluence GitHub pages currently. It has a lot of repositories. What would be the best way to try using these discharge algorithms for some river basin?
I can take that one. That's one of the projects that falls under my purview. So we don't, unfortunately, right now, we're not super set up for getting folks up and running the different SWOT Confluence algorithms. They are built as containers, so you can pull that down and execute them on your local system. But there's some pretty intricate data dependencies. One thing that might be helpful, and I'll see if I can find it, is we have an offline script, which just really is equivalent to saying, how do we run this locally? That might be a good place to start to see if it's something that you feel that you can stand up. And you can also get in touch with me, and I can put you in contact with some of the algorithm developers, that sort of thing, so we can kind of figure out what you're trying to do and like how we can help you do it.
All right. Thank you so much, Nikki. I was just checking the chat to see if I've missed any questions that may have only been posed in the chat and not in the Q&A panel, or have not received a text response. I don't see any, and now I'm going to take a look here. Looks like we received another question in the Q&A. So the next question is, since the SWOT mission is designed to observe wider rivers, will it be able to capture seasonal rivers that are typically narrow or dry but expand significantly in width during certain times of the year? Or is its river detection limited to static water bodies with consistently wide channels?
For this question, I kind of think similar to the question of are smaller rivers included. Initially, I believe with SWORD version 16, there, it was river widths that had a certain width kind of year round on average. And so we are missing some of these more ephemeral streams that might be wide, during a flood or a certain time of year, but may be dry other times of year. But there's a lot of interest in these types of streams. And so I think there's a chance that future versions of the SWOT River database may include some of these rivers that are of sufficient width, but only for certain times of year.
All right. Well, thank you so much. Just looking here to see. I don't think we've missed any question. I will do another check, but in the meantime, again, as a reminder, I will follow up. There's some post-processing after this webinar to make the recording available online. And so that will take me up to a week. And so once that's ready, I will send an email to all webinar registrants that includes a link to both, the recording, as well as links to the presentation slide decks. And we can put the links to the slide decks in the chat again. And they are also linked on the event page in Earthdata at the very bottom of the page. So you can, kind of go back and reference them if needed. Just going to earthdata.nasa.gov and then clicking on Learn and then cycling to webinars. Yes, Mira, you had a question.
Sorry, I just had one other question that came directly, but wanted to answer it, and that's the data for version D does not seem to be available in WISP and Hydrocron, and I wanted to clarify that it is available through Hydrocron, and there's some information on that documentation site. We're still in the process of ingesting it through WISP, but I figured I'd feature that since the new SWOT version D data is exciting and expected to be more accurate.
All right, excellent. Thank you. I think I covered all of the questions. So with that, what we will do next is, if there are no further questions, we'll log off from the audio component of this afternoon's webinar, but I'll leave the virtual meeting space open an additional 10 minutes or so. So if you think of something that you'd like to ask our panelists, please feel free to type that into the Q&A or the chat. And again, they will receive the Q&A and the chat logs, so they can certainly follow up with you offline. I'll just do one more quick scan. And yes, can we have a document with all the repository links? Certainly, I can try to pull all the links into, a separate PDF if that would be useful. Although I do think that most of the, if not all of the documentation that was mentioned today is also hyperlinked within the presentation slide decks, but we'll certainly do a check to make sure. That's a great question. Thank you. I don't see any additional questions. So with that, I'd like to thank my backup host, Joseph Smith, and all of our speakers and panelists this afternoon. Thank you so much for your SWOT data and tool-related content. We really appreciate it. And most importantly, we really appreciate all of you for taking time to join us this afternoon for this training. And if you did not realize it, we have another webinar tomorrow, which will focus on using Harmony services for working with level 1 and atmospheric data in the cloud. You can find that link on the earthdata.nasa.gov website. All right, everybody. Well, thank you so much. And with that, we're going to log off from the audio component, but I'll leave the virtual meeting space open. All right, take care, everybody. Thanks so much. All right, goodbye now.